Hi everyone. So in today's video, very similar to what the reading of this topic does, is create a custom panelization. And what that means is that we're going to create a panelization, but we're gonna repeat a specific geometry in a grid that's mapped onto a surface. And there are many ways to do that. But one of the simplest ways to do that is to use the definition that we see on our companion book, Grasshopper Primer, Foundations, a Grasshopper Primer by Mode Lab. So let's jump in. So what I have here is just the surface that I've started with several times before. And it's the same surface that I've been working with for all this topic. Is just this translation surface that's made with these two curves that are controlled with the graph mapper. And what I'm going to do is I'm going to segment the surface, but I'm going to use a very interesting component that's called, it's on the Transform tab on the Morph panel, and it's this surface box. And this surface box, what it does is it will get a domain, like a patch of surface, which will be just a piece of that surface, a patch. And then using the normal direction will be the direction that's perpendicular to the surface at a point. Using the normal, it'll just create 4 sides, and then it'll just create another face on top of that, so that you have like a box on the surface. So I'm going to show you how to look at that. So we're going to use this surface. We're going to reparameterize it. If you don't know what that means, go to the previous video on the playlist, and it'll be there. And then on domain, let's just go to math. And I'm going to do just first a simple domain, a domain to like here. So right now, it's from 0 to 1 on the U direction, and from 0 to 1 on the V direction. So what I'm going to do is I can just get 4 sliders that go from 0 to 1. And we can do this because we've reparameterized the surface. Otherwise, we would need to have these values a little bit. So yeah, so there we go. So we have just the surface, and as you can see, these it's a box, right? It has a height, which is this one. So I can go in Grasshopper and change that. For now it's set to 1, but I can change that to 10, for example. Or I can change that to 0.5, for example, something like that. Okay. So that's pretty much it. That's what this component does. Let me just get, I can just get a slider here for the height, and you can see that that's what that's doing. And I can also make it just a smaller box, and I can go. So that's it. So if I delete this and then I go back to the U0 to 1 and the V0 to 1, I can do what we did on the last video, which is divide that domain. I'm going to do 10 by 10. That's fine. So now I get this component now has a bunch of boxes, and they share sides, they share faces, they share side faces. Okay? So that's pretty much it. That's what we're doing, and what we're gonna do now is we're gonna create a geometry, and we're gonna map a geometry from there to these boxes. These boxes, we have this component is giving us several boxes, several twisted boxes, and they're called twisted boxes because they're not perfect. They're all these sides are pointing in different directions, but that's fine. And we can just go to height 1, and that'll be fine. So I'm going to just create a simple geometry. I'm going to create in Rhino. I'm going to create a square and a circle, just a small circle. And then I think I'm going to loft them. Something like that. Yeah, something like that. Or I can even yeah, I can do this, for example. I can do a plane. I can do this. Yeah, that's better. I can do a plane like so. Let me just go to shaded. That's a plane, and then what I'm going to do is I'm going to sort of trim that plane, and that's a surface with a hole in it, right? So now what I'm going to do is I'm going to copy this circle over here using the Alt on the, and I'm going to make it smaller, a little bit smaller. Okay. So what I'm going to do is I'm going to loft these. And that's what I'm going to do. And now what I'm going to do is I think I'm going to, yeah, I'm going to fillet surface. Radius, I think that's fine. I think I'm going to do that. I can do a larger radius. Let's do a radius 2. Let's see how that works. Oh yeah, it didn't work. Let's do radius 1. There we go. So some sort of like an interesting kind of looking. So this is fillet surface, sorry. So I'm going to join all of that into a B-rep. So that's a B-rep or a poly surface. I'm going to put that into Grasshopper just by grabbing a B-rep parameter. And then I'm going to set one B-rep like so. So that's what I got now. And what I'm going to do is I'm going to go with primitive and get the bounding box of that. So if I get the bounding box of this, that's basically what it's doing. It's getting a box that contains that whole geometry. And I think I'm done. I think I'm ready to do that, and I can hide that afterwards. So I'm going to go to transform, morph, and I'm going to do box morph. And what this does, it gets geometry, which will be this sort of trumpet-like object. And we're going to get a reference box, which will be this box. And then the target box are going to be all of these boxes that are from this component. And it'll take a while, but I think it's done. And what I'm getting now, it's a very kind of spiky looking object that has these things like that. And then this geometry can be just a bunch of things. We can have a pyramid. Let's have a pyramid that's 4 sides. It needs to be sort of four-sided geometry. But I can just change that B-rep over here, and that'll become the custom panel, like so, you know? So then we have this sort of panel there, this sort of spiky looking object. Or we can have something else entirely, which can be hexagon based. When it's hexagon based, I'm going to do a polygon with 6 sides. I'm going to draw that. And I'm going to grab this. I'm going to grab this one side. I'm going to sort of trace over one side with this line. And I'm going to move that over here. And then I'm going to create this sort of the the bounding rectangle of these curves. As you can see, these are touching right here. I can do that as well by just by using some curves, some lines. I can do this like so, and then using the intersection to get that. And then what I can do is I can sort of copy this. I'm going to copy it just a unit up to go up. And I'm going to turn this into a B-rep. So I'm going to do slab, that's the, and then I'm going to do both sides. I'm going to sort of offset this and extrude. That's what slab does. It offsets and extrudes at the same time. And I'm going to join these into a single B-rep. So that's what it is. And what I'm going to do here, as you can see, there's a little bit of overlap there. It's fine for now. What I'm going to do is I'm going to go here, and in surface I'm going to create a 2-point box, and then set 1 point over here and set the second point over here, and that gives me this box, which, as you can see, is sort of moving like that. And then I'm going to get the B-rep component and put that B-rep inside of this. So now I have a box and a B-rep, and I'm going to do the same thing. I'm just going to do transform, morph, box morph, and then this will be the geometry, this will be the reference, and then these boxes will be the target. And as you can see, I have now a pretty cool hexagon definition. I think it's a little bit too tall, so what I can do is I can just decrease the height of this. So like that, I just have a hexagonal structure there. And I can grab the original surface here and just go to surface analysis and get the B-rep edges, and then get these curved edges, and then turn those into a pipe object, which is this one right here, and just decrease the radius to 0.1, and that gives me a pretty cool definition for that. Looks though there's a little bit of a problem there. Let's see what's going on. Oh yeah, so maybe when you have a lot of curvature there, maybe you want to divide these into for example, if we're dividing this in 10, we can do 15 by 15, maybe that's it. 15 by 15, like that. That'll give me a little bit more resolution for that and makes it a little bit better. But I can also get these naked points and sort of divide them into the same amount of points, which will give me the coincident points. And then using those points, I can create a polyline and then pipe that polyline. And that'll give me these nice straight edges there. And that gives me sort of a nice hexagonal structure. Oh, sorry. And now I can just hide this. And you can render this by going to display, custom preview, and just plugging that there. I'm going to use shift to do that with the pipes. And I can get a material, which is in display, create material. And I can change the color for that material for, I don't know, let's just go with a blue kind of color. And then in here, I can go with rendered. And now I have a pretty cool Pretty interesting hexagonal panelization. There are other things that we can do with this. We can actually, right now we're controlling the height of the twisted boxes with a single number. But we could, for example, if we divide the surface with an ISO trim, let's see, where's the ISO trim? Yeah, let's reparameterize. Get the same surface, get the same domains, and then now I'm getting this kind of thing. And what I can do is, let me just don't render this and show me that instead, which is that. And what I can do is, oh, that's a little bit slow. Yeah. So what I can do now is I can get the center of this surfaces. So let's go with area. And that'll give me the centroid. That's here in surface analysis area. And now I can use an attractor much like we did in the first definition. We can get this point over here, get the distance from each one of these centroids to each one of these points. And then I can remap these numbers from their original domain to a new target domain, which could be, I don't know, let's say 1, 2, 5. Let's just say that. And that would be, that could be used to control the, let me just put this over here a little bit to the right. And then that could be used to control the height of the twisted boxes. And that's pretty cool because now I have shorter, I can get shorter boxes with, let me see if I can get the other brep. Let me see, show, and then give me this brep, set one brep. Maybe that works a little bit better. So that's kind of crazy looking, but I can remap the target domain here. It's a little bit of the charts, but I can go 0.2 to 2, for example. I get a much nicer range. Yeah, like so. Yeah, it's kind of there. So now the attractor sort of controls these. And I can also sort of invert that and use the attractor for the shorter ones, which is, yeah, the closer, yeah, it could be, or use the attractors for the, use the attractors to make them taller as they go. Like the far away ones are taller and the closer ones to the attractor are the shorter ones, which makes sense because the distance is shorter. So, but I can do that. I can do that mathematically. I can do an expression where I can get the bounds of that domain. So I can get the larger number, and I can do a subtraction and subtract the larger number from the, well, the original value from the larger number, and that could be the new value now. So that'll make the other ones larger, the ones that are close to the attractor. I'm sort of inverting the attractor definition. As you can see now, the far away ones are the closer ones. So anyways, that's something that I can do. This can be seen here, or you can see that in the rendering. There it is. So you can see that these are shorter and these are a little bit buggier now, but you get the idea. That's another thing that we can do. I'm going to internalize all of this, internalize the data, and I'm gonna get also the I'm gonna get everything internalized so that you can see the grasshopper. So that's all ready for upload. These are, you can turn this on and off. So as always, thank you for watching, and I'll see you on the next one. Remember, this was a surface panelization with a custom panel. So catch you on the next one.